What's something people don't know about the sun? If our sun suddenly turned into a magnetar, we'd all be cooked. And pretty quickly. Magnetars pack about 1.5 times the mass of our sun into an incredibly small space. They're tiny and super dense remnants of ancient stars that have gone supernova, and they have an unimaginably powerful magnetic field. Yeah, this little star would kill everything on Earth, including you. In this video, we'll show you how life would change or end if we replaced our star with some of the most extreme objects in the universe. Some of these, surprisingly, could be better for us than the sun. But before we get into it, we want to hear what object you would want to replace the sun with. Why not tell us your pick in the comments below? Oh, and welcome to We Are Around the World. Okay, now let's test them all out. Starting with a red giant. Oh my god. Oh dear. Are you filming? Yes, I'm filming. The bad news is that the sun really will swell up into this kind of red and hot exploding star, and it would swallow Mercury, Venus, and even Earth. The good news is that it'll take 5 billion years to get there, give or take. You see, our sun is what scientists call a G-type yellow dwarf. It's a main sequence star. It runs on fusing hydrogen into helium, but its clock is ticking. The sun formed 4.6 billion years ago. A star like this only has a lifespan of 10 billion years only, and when it dies it goes out with a boom, a red giant kind of boom, but we're not going to be around in 5 billion years to witness the death of the sun. So how about we speed things up and replace our star with the red giant now? Well, because that would mean instant death for you. Because, as I mentioned earlier, this red giant would swallow Earth whole. You wouldn't even get a chance to enjoy the view immediately. Mercury, Venus, and Earth would be obliterated, and not because this red giant would be so scorching hot. No, the sun's surface burns at 5,772 Kelvin. That's about 5,500 degrees Celsius or 10,000 degrees Fahrenheit. Red giants burn cooler, mostly because at this point in a star's life it's burned up all of its hydrogen. This star's surface temperature would be around 3,000 Kelvin. That's just 2,700 Celsius or 4,900 Fahrenheit. But red giants got their name for a good reason. A giant reason, I should say. Yeah, this ball of helium would be 200 times larger than the sun, and it would be anywhere from 1,000 to 5,000 times more luminous. Even if you could look at it just for a second, you'd lose your eyesight. At first, everything would become very bright and orange. The sky would look like it's on fire. You'd be blasted by the most intense heat wave as temperatures on Earth rose by hundreds of degrees. Next, the oceans would boil and disappear. Within minutes, Earth itself would get dragged into the red giant's outer atmosphere. Our planet's crust would melt. All life would burn. The red giant would reach Earth's orbit, blind us, broil us, and then there would be no more Earth left. Gone. Even Mars would get a violent blast of heat. Its carbon dioxide ice caps and permafrost would vaporize instantly, creating a thin atmosphere of gas and steam. It sounds like great news for Mars, but it's not really. Strong solar winds and intense radiation from the expanding red giant would strip away that thin atmosphere in no time. The Martian surface would be hotter than the melting point of lead. All the sand and rock on its surface would melt into a glassy blob. For a short time, Mars would glow like a red-hot coal, but then it would just end up as a dead rock. Other planets further away would be affected too because the red giant would gradually lose its mass. Its gravitational hold on Jupiter, Saturn, and the other surviving planets would weaken. Any planets that weren't burnt to a crisp would slowly drift away out into outer space. Okay, that was a pretty violent end for Earth. On a scale of how spectacularly we die, I'd rate it a 9 out of 10, taking a point away for not being able to enjoy the view even briefly. Swapping our sun out for a red giant brought instant death. No time to react, just vaporized. Terrifying. Yeah, but hey, sometimes instant can be a good thing. Like when you're trying to get AI tools to actually work together. AI tools are everywhere these days. Some write, some code, and some generate videos or images. But juggling all of them is chaotic, time-consuming, and expensive. That's why Chat LLM Teams was created. I'm talking about a single, powerful platform that brings all the top AI models together in one place. You get access to ChatGPT 4.1, ChatGPT 04 Mini High, Claude Sonnet, Gemini 2.5 Pro, Grow 3, DeepSeek, and more. You don't even have to choose which one to use. Root LLM picks the best model automatically based on your prompt. No guesswork, no switching tabs. Need visuals for a dwarf star swapping places with our sun? Well, Chat LLM Teams gives you access to some of the best AI image and video generators out there, all on one platform. It even has a humanize feature to make the AI written stuff sound, well, not like a robot. You can also build websites, apps, and presentations with Deep Agent, generate documents and slides with Deep Research, and even write code using the built-in Code LLM editor. The best part, the price, just $10 a month. Visit chatlm.abacus.ai or click in the link in the description and try it now. One platform with all the AI power you need. Okay, time to chill. Next, let's go a little easier on Earth and replace the sun with a red dwarf star. Red dwarf stars aren't the same as red giants. These are the most common types of stars in the universe, and it's we find out there in space are orbiting this kind of star. Now, the sun will never become a red dwarf, not even in billions of years. But if it did, well, it wouldn't be so bad. First, it would become really small and dim. Red dwarfs are much cooler than our yellow dwarf sun. Their average surface temperature is about 3,300 Kelvin. That's 3,000 degrees Celsius, 5,500 degrees Fahrenheit. Replacing the sun with this kind of star would cause the skies on Earth to look dark and faintly colored. It'd be like a deep dusk or dawn, even at noon, with a small reddish-orange dot. It's so dim that you could look directly at the red dwarf for a brief moment without any eye damage. But because this new sun would be so dim, temperatures on Earth would start to drop by a lot. Within 1 week, the global surface temperature would fall below -8 degrees Celsius. That's 0 Fahrenheit. Within a year, Earth would be about -73 degrees Celsius, -100 Fahrenheit. The effect of this cooling would take time, but eventually everything would freeze. The only place left that would still have liquid water would be deep under the oceans. At first you'd see intense storms and heavy snowfalls, but eventually the water cycle would stop. There'd be no rain, no snow, no wind. Then there wouldn't be enough solar energy for plants to perform photosynthesis. Plants would be the first thing to die out, and soon after the entire food chain would collapse. In this climate, only the hardiest microbes would have a chance. Some microorganisms deep in the Earth's crust or around hydrothermal vents in the ocean could survive indefinitely. But on the frozen surface, all forms of life would be wiped out. Over the years, the cold would become more intense and even the near-surface bacteria would go dormant or die. Earth would become a sterile, ice-bound rock. Now, it wouldn't be all that bad because at least you wouldn't die instantly. You might have a chance to leave the planet and travel someplace more pleasant. That is, unless Earth itself took off out of its orbit. Here's the deal with red dwarfs. They're way less massive than the sun, so their gravitational pull in the solar system wouldn't be strong enough to keep all the planets in place. Earth might break off and become a rogue traveler in deep space, getting even colder, darker, and more inhospitable for life. And that would happen fast. Gravity travels at the speed of light. So, Earth would start feeling the change as soon as 8 minutes after the sun turned into a red dwarf. Our planet wouldn't immediately shoot off into deep space. No, it would gradually begin drifting away and then eventually we'd leave the solar system, but at least you'd still have a little time before your imminent death. So a red dwarf filling in for the sun, well, I give that a 4 out of 10. Okay, let's move on to something that's not very common in the universe. Turn our sun into a blue star. A blue star. Blue stars might look cold, but they actually run extremely hot. These O-type or B-type main sequence stars are the hottest and most massive stars in the universe. You don't see them very often. O-type blue stars make up only about 0.00003% of stars in our Milky Way galaxy, and our sun physically could never gain enough mass to become a blue star, but if it did, it would look interesting. Daytime on Earth would have an intense, almost stark blue-white glare. The sky would take on a deeper blue or even a violet tint. This blue star would be a lot brighter than the sun. Do not look at it with the naked eye. This bluish light would be overwhelming. Oh, and did I mention it would shower you in extreme levels of radiation? Yeah, blue stars are monstrous. The blue supergiant star Riel emits 60,000 times as much energy as our sun. And some blue stars out there like Eta Carina put out 1 million times the energy of the sun. Even if our new blue sun were a less extreme blue star, well, Earth would suddenly be receiving hundreds to thousands of times more radiation. If you were exposed to this blue sun just for a few seconds, you'd get an instant sunburn from all the UV radiation. And, just as quickly, the Earth's surface would start to heat up. Instead of a global average of 15 degrees Celsius or 60 Fahrenheit, you'd be dealing with temperatures of several hundreds to thousands of degrees. In a matter of days or weeks, Earth would heat up to the point where rocks and metals melt, the oceans would boil away, and all life would incinerate. That would be the end of Earth. The good news is that if this blue star had the same mass as the Sun, well, nothing else would change in the solar system. Would Mars become a little more habitable? No, but it would become less deadly than Earth for a short time. It would get warmer on the red planet. But the amount of radiation the blue star would bathe Mars in, well, let's just say we wouldn't want to be building habitats there. Blue star, I give it a 5 out of 10. Deadly, but not as dramatic as the red giant. You know, Chase has been dying to go to a star for his next mission, but we're not exactly sure where to send him. What star do you think we should send Chase to? Well, tell us in the comments below. Now let's see if we can crank it up a notch and turn our sun into a neutron star. Neutron stars are epic. They're born out of a massive explosion called a supernova. It's one of the most violent and energetic events in the universe. The whole blast only lasts about 1 second, but in that second, a star releases 99% of its energy. This mega event can outshine the galaxy for weeks. Of course, there's no way you are surviving this kind of blast. Our sun is way too small to burst into a supernova anyway. So, let's skip the initial blast and replace the sun with a neutron star in a more calm way like this. Within 8 minutes of the last drop of sunlight, the sky would fade to black and stars would appear. Even if it were daytime, you wouldn't see the moon or the planets because you can only see them by reflected sunlight. You wouldn't even see the neutron star in the sky. It would be practically invisible to your human eyes. From now on, it's forever night on Earth. And you probably know where this is going. Without sunlight, there'd be no photosynthesis, no plants, no life. Earth would gradually become a frozen rock, but it would be bathed in a different kind of solar energy. Neutron stars are unimaginably energetic, especially if they're pulsars. If this neutron star had a spinning core, that would make its magnetic field stronger. It would become a rotating magnetized neutron star or a pulsar. And now you'd be dealing with periodic blasts of intense high-energy radiation. From Earth, these bursts would appear as an aurora-like glowing in the sky. With time, the effects of this radiation would become more intense and cause electronic disruptions, skin burns, and radiation sickness. Life on the surface would be wiped out from two sides, freezing from a lack of solar heating and being irradiated by the neutron star's high energy. Earth would freeze and fry at the same time. But once you zoom out a bit, things would be business as usual. The neutron star would have about the same mass as the sun, so it wouldn't disrupt the solar system's delicate orbital order. Neutron stars are way too radioactive, they sound epic. I wouldn't want to live close to one, so I'm gonna give it 7 out of 10 on the destruction scale. Okay, next up, let's replace the sun with a magnetar. Magnetars are extreme, maybe more extreme than neutron stars. Well, technically, magnetars are neutron stars just with a little sprinkle of magnetism. And just like neutron stars, magnetars are small, about 20 kilometers or 12 miles across, but their magnetic fields are trillions of times stronger than Earth's. Then here's a bummer. If you expect this kind of view, well, don't. Because if the sun suddenly turned into a magnetar, you wouldn't see anything in the sky. That's because magnetars emit most of their energy in X-rays and gamma rays, not in any visible light you could see. Once again, just like with Jimmy Neutron's star, it would be all night and no moon. And here's another interesting thing about magnetars. These things are burning hot. I mean, all these stars are. But a magnetar's surface temperature is millions of degrees. But on Earth, you wouldn't get all that much heat from one. Again, they radiate their energy as X-rays and gamma rays, not as visible or infrared light that would warm Earth's surface. Plus, a magnetar surface area is really tiny. So just like in the case of a neutron star, Earth would be blasted by deadly radiation and it would freeze because of a lack of warming light. But unlike the neutron star, a magnetar would instantly fry our satellites and power grids. Its radiation is way deadlier, and it would also completely disrupt the Earth's magnetic field. A magnetar's intense magnetic field and gamma-ray flares would violently compress the Earth's magnetosphere. And you want the Earth to have a stable magnetosphere because that's what holds the atmosphere in place and protects you and me from space radiation. Not only would Earth become technologically blind and deaf, it would also be showered in so much radiation you might turn into the Hulk. Yeah, brother. No, not that one. The one who turns green. Well, that really only works in the Marvel universe. But hey, at least you'd get the view. There'd be incredible auroras in the sky. I was really looking forward to a Magnetar. Epic, that's an 8 out of 10. Next up, the scariest and hungriest object in the universe, the black hole. Yeah, remember how I said that some of these extreme objects might be better for Earth than the sun? Well, scratch that. Nothing is better than the sun. And a black hole is definitely much worse. To be a little more gentle to our planet, well, let's say that this new black hole in the center of our solar system had the exact same mass as the sun. Because a supermassive black hole, yeah, that one would just suck you in and not spit you out. But a nice sun-masked black hole wouldn't even disrupt the Earth's orbit. This epic view from Earth. Wait, that's not right. If our sun was turned into a black hole, you wouldn't see a fiery disk in the sky anymore. There'd just be, well, just nothing. That's because a black hole with the same mass as our sun would only be about 6 kilometers, 3.5 miles wide. Bummer, I know, but grab a telescope. You'll see that the space where the sun used to be isn't completely empty. You see, black holes bend light around them, and without the sun's blinding glare, you'd start noticing the stars in the background being smeared into arcs. This effect is called gravitational lensing, and it's really the only way you could see the black hole at all. If some distant star lined up just behind the black hole, you'd see something called an Einstein ring, a perfect circle of starlight wrapped around a pitch-black shadow. But like I say, you'd need a telescope to see it. Now, as far as life on Earth goes, well, you and everyone around you would soon freeze to death. Maybe not immediately or overnight because Earth would still have some internal heat, but after a few years, almost everything at or near the surface would be frozen solid. After millions of years, Earth's equilibrium temperature would get as cold as minus 240 degrees Celsius. That's around 35 Kelvin or minus 400 degrees Fahrenheit. That's a complete freeze over. Nothing would survive here. But on the bright side, at least you didn't get sucked into a black hole, so that's a 6 out of 10 for me. Black holes are dangerous and very strange. Even a nanosecond in one would stretch you out into a state of human spaghetti. Now, the closest one of these monstrosities is just 1,500 light-years away, and I wouldn't recommend jumping into it. If you did, it would be a cosmic nightmare or a trip to a parallel universe. But that's a story for another What If.